Assalamu alaikum. Today we're going to draw the graph of the reciprocal functions, that is cosec x, sec x and cot x. We know that cosec x is the reciprocal function of sine and sec x is 1 upon cos x and cot x is actually the reciprocal function of tan x. Okay, let's draw the graph of sine x very quickly. Okay, as far as the graph of sine x is concerned, we know sine is 0 at 0, 180 and at 360, and sine is 1 at 90 and negative 1 at 270. Okay, if I have to draw the graph of sine x here, zero, 180 and 360, 0. The maximum point on the graph of sine x is 1. It doesn't go beyond that, normal sine x graph. And the minimum point is negative 1. Okay, let's start with drawing the graph then. Okay, we know the maximum point is 1, so at 90 it's going to go at the maximum point, at 270 is going to go to the minimum point. This is the graph of sine x. In terms of radians, if you want to write, in place of 90 you will write pi by 2, pi, 3 upon 2 pi and 2 pi. Okay, now if I have to draw the graph of cosec x, what I have to do is, we know because cosec is the reciprocal of sine, so 1 upon sine is cosec. So 1 upon 0 we know is infinity, so sine is going to go to infinity. The graph of cosec x is going to go to infinity at 0, 180 and 360. It is going to be 1 at 90 only, and it's going to be negative 1 at 270 only, because 1 upon 1 is 1 only and 1 upon negative 1 is negative 1 only. Okay, what I'm going to do in order to draw the graph would be, okay, I'm going to draw a vertical asymptote at the point 0, 180, okay, here 180 and 360. So I'm drawing dotted line here to show that here the graph is going to go at infinity. At 90 I'm going to mark the point 1 only, and at 270 I'm going to mark the point negative 1. Okay, now I know that the graph is going to start from at 0, it's undefined, and the graph is going to come like this. Likewise it will continue like this, and if it has to go in the fourth quadrant, obviously it's going to be in the fourth quadrant, or on the negative side also. If you want, you can draw it this way. It will be like this. Okay, why am I drawing the graph like this? The reason being, 0 upon 0 is 1 upon 0, 1 upon 0 is undefined, so at 0, 180 and 360 it will be undefined. Now as far as this point is concerned, these points have gone here. The reason being, if you divide 1 upon any number between 0 and 1, like 1 upon say 0.5, it will become 2, so it will go on to 2. And if it's 1 divided by 0.25, it will go on to 4. So 1 divided by any small number will become a large number. Okay, likewise 1 divided by any negative small number between 0 and 1 will become a negative large number. And here also 1 divided by, for instance, a 0.75 is going to become a large number here. So that's why it's going to be like this. Okay, moving on to the graph of cos x now. We know cos of 0 is 1 and cos of 360 is also cos 360 is also 1. cos of 90 we know is a 0, and cos of 270 is also a 0, and cos of 180 is a negative 1. Okay, let's draw the graph of cos of x here. This is the graph of cos of x. Now if I have to draw the graph of sec of x, okay, 1 divided by a 1 is 1. Okay, that means at 0 and 360 it will be 1 only, but at 90 and 270 it will be undefined. So I have to draw a dotted line at 90 and 270 in case of a cos sec graph. Wherever the graph of the original trigonometric function has become 0, like in case of sine it has become 0 at 0, 180 and 360, you will have to draw the vertical asymptotes at the same points, and at this the graph is going to come very close to the asymptote but will not touch the asymptote and it will go parallel to it. Likewise here also the graph of cos is becoming 0 at 90 and 270, so I'm going to draw the vertical asymptotes at 90 and 120. Sorry, 90 and 270. Okay, at 180 it was becoming negative, so negative 1, so 1 divided by negative 1 is negative 1 only, so it will be negative 1 only here. And okay, and 1 divided by 1 is 1, so it's going to be like this, so it will go like this, it will become undefined here. 360 also it's going to be 1 divided by 1 is 1, so it's going to be like this. Okay, so this is the graph of sec x. It continues on the negative side also in the same way, so it's going to be like this. Okay, and even beyond 360 if you want to continue it will be like this. Okay, now moving on to the graph of tan x. We know tan is 0 at 0, tan is 180 at 180 also tan is 0, and at 360 also tan is 0, just like sine. Now tan is undefined at 90, is undefined here, and tan of 270 is also undefined. Now let's draw the graph of tan. We know one cycle of tan finishes at 180 degrees, and after 180 the second cycle starts. At 90 it's undefined, and at 270 also it's undefined, so we can draw the vertical asymptotes at 90 and 270. Okay, tan is 0 at 0, at 180 it's 0, and 360 is 0. We know tan of 45 degrees is 1 equals to 1, so it's going to touch 1 at 45 degrees here. Okay, at 135 degrees it is negative 1, because in the second quadrant tan is negative. Tan of 225 degrees is 1, and tan of 315 degrees is negative 1. Okay, fine, let's draw it. Okay, so I'm just going to draw this here. Tan of 45 is 1, tan of 135 is negative 1, tan of 225 is positive 1, tan of 315 is negative 1. Okay, so in order to draw the graph, I'm just going to join the points, and it's going to go very close to the asymptote, and then it's going to go vertical parallel to it. This is the first period which has finished. Now starting from with the second one. So 2 complete oscillations or 2 complete cycles up till 360. Now if I have to draw the graph of cot of x, okay, so 1 divided by 0 is undefined. That means tan is going to become 1 divided by 0 at undefined at 0, 180 and 360. So at 0 it's going to be undefined, at 180 also it's going to be undefined, and at 360 also it's going to be undefined. So you have to draw the vertical asymptotes at 0, 180 and 360. Okay, tan of 90 was undefined. So tan of 90 was undefined. So cot of 90 is going to be 1 upon undefined, which is a 0. That means going to touch the graph at 0 at 90 and also at 270. 1 upon undefined is 0. So it's going to be at 90 and 270 is going to touch 0. Okay. So we're going to start drawing the graph. It's going to come like this. The reason why am I putting it on this side is that 1 divided by any number between 0 and 1, for instance 0.5, 1 divided by 0.5 gives you 2. So it will be a large positive number, and likewise if it's a negative number here, it will become a large negative number on this side. So that's how we're going to draw the graph of cortex. This is the graph of cortex. Okay, moving on to a few questions which I've taken up. Let's do them. Okay. The first question which I'm picking up here is, I'm just writing down the question very quickly here. Just hold on. Okay, for instance, if I have to draw the graph of y equals to 5 cosec x minus 3. Okay, in order to get the maximum and the minimum point of the graph, we know this is the amplitude of the graph and this is the axis, amplitude, and this is the axis. Okay, once you do axis plus amplitude and axis minus amplitude, it will give you a 2 and a negative 8. That means the maximum point of the graph is 2 and the minimum point is negative 8. Okay. Okay. If I do it in terms of radians, it will be pi, 2 pi here, pi by 2, which is 90, and 3 upon 2 pi. And I have to draw the graph of cosec x. So it's going to be, we know the graph of sin x used to be 0 at 0, 180 and 360. Now it's going to be undefined at 0, 180 and 360. Okay, it will be positive. The maximum point will be this and the minimum point will be this. And you just have to simply draw the graph. This is the graph of 5 cosec x minus 3. Now if I have to draw the graph of, say, y equals to 2 sec x plus, say, 4. In that case, you know that the maximum point is going to be axis plus amplitude, axis minus amplitude. The maximum point is 6 and the minimum point is 6. Minimum point is 2. Okay, and if I have to draw the graph, for instance, this graph I have to draw from negative 180 to positive 180. Or in terms of radians, if I say from negative pi to positive pi. This is pi by 2, which is 90, and pi here. Negative pi by 2 and negative pi here. We know cos becomes undefined at cos of 0 was 0 at cos of 0 was 0 at pi by 2 and 3 upon 2 pi. So at pi by 2, I'm going to draw a vertical asymptote here and another vertical asymptote at this point. Okay, so cos used to be 1 at, okay, the maximum point here is 6 and the minimum point is negative 2, so which I'm mentioning here. Now the axis is 4. So this is the axis. Okay, and I have to draw the graph of sec now. So if you remember, cos used to be positive 1 at 1 only, maximum point here and here. So the graph is going to be somewhat like this. It will go like this, and here it's going to be negative like this. This is the graph of 2 sec x plus 4. Okay, let's do another one. I have to look for the question. I've written it somewhere. Just hold on. Okay, yeah. The question is sketch on the same diagram, writing down the question. Sketch on the same axis in the interval from negative 180 to 180 the graphs of y equals to cot x and y equals to x, and deduce the number of solutions. Deduce the number of solutions of cot of x plus x equals to 0. First of all, you have to draw the graph of cot x. Okay, from 180 till negative 180 to 180. Okay, so at 180 it's going to become undefined. And negative 180 it will become undefined as well. Okay, and at 90 it will be touching 0. Negative 90 it will be touching 0. Okay, so it's going to be like this. Achha, the maximum point is 1 only, and minimum point is going to be negative 1. This is the graph of cot x. This is the graph of cot x. Now I have to draw the graph of y equals to x, which will be somewhat like this. Okay, y equals to x positive x, so it's going to be somewhat like this. Okay, number of solutions, if you see, 1 and 2. Total number of solutions. Now this is actually, this if you want me to explain, y equals to cot x and y equals to x. When you write them, solve them simultaneously using the substitution method, since y is the subject in both, you can write cot x equals to x, and then eventually, sorry, this should be a negative sign here, minus here. When x shifts to this side, it will become cot x minus x equals to 0. Okay, this brings let's sketch another one, which is sketch y equals to sec of 2 theta. Okay, now if it's 2 theta, that means generally the graph of cos finishes one rotation in 360, but now it's going to finish it in 180. That means it will have 2 rotations up to 360. So you have to draw two rotations up to 360. So if it's 360 and this is 180, so it will finish one rotation at 180. Okay, so for sec x, sec used to be cos. If you remember, try to remember, cos used to be 0 at 90, and 270 it used to be a 0. Okay, I'm writing it here. 90, at 90 cos used to be a 0, and at 270 now we have to draw we have to generally, for a graph of sec x, sec theta only, you have to draw the asymptote at 90 and 270. But now since these are two rotations in the same, so at 45 we're going to draw the vertical asymptote here. This is 45. You draw the vertical asymptote here, and 270 divided by 2 is 135, so you draw another vertical asymptote here. Okay, and sec used to cos used to be 1 at 0 and 360. Now it's going to be at 0 and 180. Okay, so this will be the graph of cos. If one rotation has finished, then you can complete the next rotation here. Keep on drawing the same. That is it. So this is also done. Thanks a lot for watching the video.